Hi guys, today a novum, my first review. A company called Vevor contacted me and asked me if I wanted to test and review one of their ultrasonic cleaners. The name Vevor was known to me because I saw them many times when I was looking at AliExpress. I was looking for infrared cameras, and many times I saw that they are advertising a lot of models for ultrasonic cleaners from, I don't know, a couple of liters up to 30 liters or something. There is a really wide variety of models they have. Honestly, many times I thought, okay, it's nice to have an ultrasonic cleaner to clean some mechanics or dirty stuff, or PCBs mostly in my case. But you know, I'm in the prototyping business, and prototyping the boards, the most I would do by hand or reflowing is 7 pieces. Until now I cleaned them by hand. But anyway, I thought, yeah, wasn't sure at the beginning. I wrote to them, yes, but only under the condition that it will be a 100% honest review, highlighting the good and all the negative and perhaps dangerous stuff. Anyway, I received it. It looks very well, as it is in the advertisement. I saw many videos of these things on YouTube, and let's take a look what it is. It's a 15-liter ultrasonic cleaner. It has 360 watts ultrasonic power, energy, or whatever you want to say it. 400 or 450 watt. In the description it says 400, in the label behind it says 450 heating power. Heating is quite slow, but it works. So the mechanics of this thing are nice. Let me turn it around. You have 2 handles, one on both sides. The good thing is it is all stainless steel, and nothing is sharp, nothing will cut my fingers and anything. This is the back of the unit. It's a JPS-60A, 15 liter. You see here it says power 450 watts. Anyway, whatever it is, you have an IC socket, fuse and switch combination, and very interesting, or very practical, on the side you have this valve, this water release, this draining valve, because if you have here, I don't know, 14 liters or something, or 13 liters of water, this thing is heavy as hell. You cannot move it. So this is what we have here. Let's see what's inside. It looks like a rice cooker or like a fries cooker, more or less, but it's very well done. Everything is stainless steel. The casing itself, with this texture, with this diamond texture, I don't know how to call it, yeah, rhombic texture, etc., is nice, but it's very thin. It is, I don't know, half a millimeter or something. This is good and bad. The good thing is that it is not that heavy. The bad thing is that it is a cavity, and this thing vibrates like a loudspeaker. Okay, let's see what's inside. You have a hose necessary. We have an adapter for the valve. You have a Teflon tape. That's more or less not necessary, because this thing is plastic and seals itself automatically. You have a description that is, yeah, more or less okay. And you have the basket. The basket is okay. honestly, I would have preferred a basket that has the handles over the lips of the cavity and is not touching the bottom, but is just hanging in there. This would be much better, but it is okay. The ultrasonic cavity, the tank itself, it's really nice. They made it really nice. This is okay, there's nothing to say about that. Yeah? Here you see the 3 and 3 positions where this doesn't look good, huh? Where the 3 transducers, the ultrasonic transducers are mounted. Further, you have a filter so that not the thick stuff is going through the valve and clutters it. As I said, everything is quite nicely made and nothing is sharp. So let's start it. This is what you get when you, this is the greeting what you get when you start it. The display and keyboard, they are so easy to use. There is no necessity of a description or anything. You have 2 buttons. You have on the left side, you have the temperature panel, and on the right side you have the ultrasonic panel. The temperature panel is divided in 2 sections. The left side is the set section and the right side, the 2 digits, is the actual temperature. It shows 24 degrees. Yeah, this is what it thinks it is in the room temperature, but it's not correct. This thing is, yeah, you see it's going down. I have 22 degrees, 23 degrees, that's okay. We have temperature plus minus and on off. That's it. It takes a while, at least almost 1 hour to get it at 60 degrees when the tank is full. So I suggest to put some warm water inside or use a dedicated heater, an aquarium heater or something to help it a little bit to get up to the temperature faster. On the right side you have minutes and seconds for the ultrasonic. 30 minutes is maximum and on off, that's it. What I'm missing here is a degas function, so that you can degas the liquid before you put your things inside. You have to clean, but this is not a problem because you can put the unit to work for 10 minutes and this will degas the liquid automatically, and then put your utilities you have to clean inside and start your cleaning session. So this is how the whole thing looks and how it works. There is a problem all through here that when I was playing with this unit for a while, it works perfectly, you will see, but this thing vibrates and vibrates a lot. Yeah, it is because of this thin metal sheet, this thin stainless steel, but is really like a cavity, like a sound cavity. And whoops, let's go a little bit down. The next thing is, when I was playing with it, it started to rattle, like something is loose inside. I took a look, and I wanted to stop it, and I couldn't stop it because I was pressing this button here, and it's like I was pressing in air. Nothing. That's nothing behind. There's no button behind. These 2 buttons were not reacting. Anyway, I turned it off on the back, drained the water, opened it, because I would open it so or so to make a tear down. Yeah, by the way, I'm not sure if the tear down will be in this video or in the next one, because I will make a complete tear down and a complete reverse engineering of one of the power boards, power drivers, ultrasonic drivers that's inside. But I'm not sure if I will make it in this video. Depends how this video will go and how long it will last. Yeah. Anyway, I opened it, and there are 3 screws here that are holding the PCB behind the faceplate, and because of the vibrations, 2 of them were loose. One of them was almost to fall inside to the power boards. That could be a catastrophe, a bang, because everything there is mains, yeah. And the other one was completely loose. Yeah, the fix was very easy. Just fastened the loose bolts, the loose nuts, and that's it. But this is not a solution. Vevor, when you see this video, please make a change and a modification. Do not use normal nuts, use self-locking nuts. This costs nothing and solves a massive problem, a possible massive problem. You will see the same problem is on the IEC socket on the earthing. The earthing itself, because I opened it already, is connected nice, but due to the vibrations, it will get loose. And then you have the earth not connected on the case anymore. That can be bad. And that can be solved again just with a self-locking nut. Let me show you what I mean. Nothing magical. This is how self-locking nuts look. M3 self-locking nuts. The cost of these are nothing. And it solves all the problems that I saw with this ultrasonic cleaner. Everything else is more or less okay, yeah. But the fastening of the PCB for the keyboard and display and the earthing of the IC socket is a problem. These nuts should be used to avoid this problem. That's the solution, nothing else. No big solution, just use these nuts. This is how the bottom side looks. Again, this nice texture, diamond shape or rhomb shaped, I don't know. It's very nice done. The fan. You see here the 3 boards are mounted with the exhausts. The first positive thing is that I see that there are no self-tappers. These are nice 3mm screws. So nothing very spectacular on the bottom, but just I wanted to show it to you how it looks. So this is how it looks inside. For us, the power electronics are the interesting part. The whole system consists of 3 boards, 3 power boards. Each power board has a lines filter here, and the rest of the electronics. There is not really much to say, because these are probably self-oscillating oscillators. There is no special chip or anything. There is nothing on the bottom. So this thing is a complete self-oscillating. It produces probably a high voltage, a few hundred volts probably, that goes to the 6 transducers. The transducers are nicely mounted on the bottom. Each of these boards controls 2 transducers. And the third board is, I don't know if you can say the main board, that has a power supply, an auxiliary power supply on it. The power supply is for the logic voltage of this, of the control panel on the front, and of course for the fan, connected with this cable directly to the control board. The cabling is, yeah, okay. Could have been done much better. Everything is black and red, but okay, it works. What I don't like is that the mains, they're not used different cables. Just everything is black and red. This is the mains input. The good thing is that the isolation is silicone, so it withstands higher temperatures. In the middle here, you see the heating. There are two heating elements, splitted. They are very small, very narrow, and this is the reason why it takes ages or so long for the water to reach the temperature you set on the display. Otherwise, it is not bad at all. It is a nice construction. Just remind yourself, this is a 160 euros appliance. And as we will see, it works perfect. Here we see the temperature sensor. And again, the heaters, the two heaters. Temperature sensor is completely on the corner. So, two test boards. Look at that. How they look. Crusty. That's a design I made 2018. This is the first prototype that has been soldered from employee of the company that I made it for. Over 1,000 pieces of this thing have been assembled. This is one of the boards that we will test, and two more boards. Let's see. Look how awful they look. Crusty. Of course, I made them extra crusty just to see it better. So, sorry, let's make the obligatory test with the aluminum foil that shows that this thing works and produces ultrasound. Let's go. That's enough to see. Look at that. We made Swiss cheese everywhere. On all sides. You see everywhere where the transducers are. Look at that. So, okay, just to show you. Okay, hello in my kitchen. This is the only place I can test this. Okay, I set it to 60 degrees. We have already 46 degrees the water. I pre-warmed it a little bit. I set to 13 minutes degassing. I cannot activate it because if I activate it now, you will not hear anything anymore. You will see what I mean. So this is how it looks. I filled the tank up to the brim with normal tap water, and this plastic jar where I put the PCBs inside is I put distilled water and this ultrasonic cleaner. I don't know if it's good for anything, but I'm trying it. I think it will work, but look what happens when I start. You see what I mean? You cannot hear nothing. And the finished ones, let's take them out. We're already down to 44 degrees. It's quite dirty inside. Okay, these are the results. I will show you in a minute. I want to show you how much water I put inside, probably too much, but it should be at least 2/3 of the cavity, so that the energy that comes from the transducers, the hypersonic transducers, the ultrasonic transducers, sorry, is distributed in the water in the cavity, and you don't have SWRs, standing waves that go back to the transducers itself. Think about this thing like a transmitter. Water is the antenna, the cavity is the antenna. If you have a bad antenna and most of the power is going back to the transmitter, it will destroy the transmitter. The same is here with the transducers. So, let me show you how this looks. Of course there is a little bit still, but this is very bad soldered. It is so much cleaner than before. And I'm sure I didn't use the correct solution. It was just a soap solution, more or less, yeah. So this is the one. Now we have the other one. Look at this. Almost completely clean. 15 minutes, 10 minutes, also 7.5 minutes each side. Look at that. Almost spotless. Almost. The second one here, we have some residue. Okay, that was my first time, and to be honest, I'm very pleased from what I see. Look at that. Nice. Well, looks good. Thumbs up, it works. This has a learning curve. I have to learn how to clean these things better. What jars, what solutions I need, etc. But for the first time and the first test at all, I like it. I like it. So that's for today. Thank you for watching. Thank you for watching my first review. I hope you liked it. Every review that comes from now on, will be like that, completely honest. Otherwise I will not do it. Yeah, and I will highlight the good and the bad. So thanks again for watching. See you next time. Cheers.